Hello, friend. Welcome to Science for Sleep. Earth can feel so ordinary that most of us rarely stop to notice how unusual that feeling really is. The air does not seem remarkable when it moves softly across your skin. Gravity does not seem remarkable when your feet stay on the ground without effort. A glass of water does not seem remarkable when it waits quietly on a table, clear and calm and easy to drink. Even the sky can seem like a simple backdrop, something that is always there, so familiar that it almost disappears from thought. Yet so much of what feels ordinary on Earth only feels that way because many quiet systems are working together all the time. One of the simplest ways to notice this is through temperature. Without Earth's natural greenhouse effect, the planet would be far colder than it is now. The warmth most people take for granted is not only a gift from sunlight. Part of it comes from the atmosphere holding on to some of the heat that rises from the surface. The ground warming under the sun, the evening cooling slowly instead of all at once, and the fact that water can remain liquid across much of the planet all depend on that quiet balance overhead. Light itself is being managed too. Earth does not simply absorb everything the sun sends its way. Some sunlight is reflected back into space, while the rest is absorbed by the atmosphere and surface in a balance that helps keep conditions from swinging too far in one direction. Clouds, ice, land, and water all play their part in this exchange. In a strange way, the brightness of a cloud, the pale shine of ice, and the darker stillness of the sea all belong to the same planetary conversation. Water may be the easiest part of this balance to feel in daily life, and also one of the most extraordinary. Earth is the only planet in our solar system known to have stable liquid water on its surface today. That fact hides inside ordinary moments so easily that it almost slips by unnoticed. It is there in rain tapping on a window, in rivers moving around stones, in waves folding onto a shore, in steam rising from a mug, and in the simple comfort of swallowing cool water when you are thirsty. On Earth, water moves openly across the surface, linking clouds to streams, streams to oceans, and oceans back to clouds again. The sky above you is not only beautiful, it is protective. Many small meteoroids enter Earth's atmosphere, and many burn up before they ever reach the ground. A shooting star can look delicate from below, just a brief line of light passing through the dark. But often that light is the sign of a small piece of space debris meeting the air at great speed and losing itself there. The atmosphere is not just something we breathe. It softens extremes, carries warmth, scatters light, and often takes the first contact with what falls toward us from space. If you enjoy these quiet journeys, please subscribe, and feel free to leave a comment sharing where you're listening from tonight. There is another shield as well, one that cannot be seen in the way clouds or sunsets can. Earth's magnetic field surrounds the planet in an invisible protective bubble. Most people never feel this field directly. It does not brush against the skin the way air does, yet it is there, stretched around the planet, helping protect Earth from charged particles flowing outward from the sun. Sometimes, near the poles, its presence becomes visible in auroras, where the sky glows in soft curtains of light. Taken one at a time, these facts can sound almost simple. Air holds some heat. Water stays liquid. Sunlight is partly reflected. small rocks burn in the sky. An invisible magnetic field helps stand guard around the planet. But taken together, they begin to change the feeling of standing here. Earth does not feel calm and workable because planets naturally have to be this way. It feels calm and workable because many conditions are aligned at once and because several of them keep helping one another from moment to moment. Earth feels ordinary only because so much is quietly going right. A habitable planet is not the same thing as a comfortable planet. That may sound strange at first, because when people hear the word habitable, they often imagine something gentle and easy. Blue water, mild weather, soft air, green land, a place that seems ready for life the moment you arrive. But in science, habitability means something simpler, and in some ways more interesting. A habitable world is not a world where everything is perfect. It is a world where enough important conditions stay within the right range for long enough that life has a chance to exist, continue, and adapt. That idea matters because Earth does not stay livable by being still. It stays livable by staying workable. Life does not need every day to be warm and calm. It does not need every place to be easy. In fact, Earth contains deserts, ice sheets, dry valleys, storm belts, deep oceans, high mountains, and volcanic zones. Many parts of this planet are difficult places to live. Some are difficult even to visit. Yet Earth, as a whole, remains habitable because the planet provides a broad, long-lasting setting where water can remain liquid, energy is available, useful chemicals are present, and conditions do not swing so wildly that life has no time to respond. That is the key difference. Habitability is not about perfection. It is about stability with room for change. A planet can be bright, beautiful, and still be hostile. A planet can have weather and still be unlivable. A planet can even have water in some form and still not offer a good home for life at the surface. What matters is how many pieces come together at once. Does the world have a steady source of energy? Does it have the right temperatures often enough? Can liquid water exist, not just briefly, but over long periods? Is there enough atmosphere to support pressure at the surface? Are the basic chemical ingredients there? And perhaps most importantly, can those conditions last? Time is one of the quietest parts of habitability, but it may be one of the most important. Life does not appear, grow, and reshape a planet in a moment. It needs long stretches of continuity. It needs cycles that repeat. It needs conditions that do not collapse every few thousand years or swing so sharply that every gain is erased. Earth has changed many times, but again and again it has stayed within a range where life could continue. That long stability gave oceans time to cycle, rocks time to weather, ecosystems time to spread, and living things time to slowly transform the world they lived on. In that sense, habitability is less like a switch that is either on or off, and more like a range a planet can remain inside. Earth sits within that range because several systems support one another. The atmosphere helps manage temperature. Water moves heat and matter around the surface. The planet's distance from the sun keeps sunlight within a workable range. The oceans store warmth. The ground and air exchange gases. The deeper interior of the planet stays active. None of these things alone would fully explain Earth's livability. Together, they create a world that is not perfect, but balanced enough. That is also why Earth feels so ordinary to us. We were born inside the range. We live inside the range. Our bodies, habits, cities, crops, and calendars all developed inside it. So the right level of warmth does not feel like a rare planetary condition. It just feels like spring, or shade, or a cool evening. Air pressure does not feel like a technical requirement for surface water. It just feels like normal air. The steady pull of gravity does not feel like part of habitability. It just feels like standing. But so much of what feels normal is actually part of the larger pattern. To call Earth habitable is not to say Earth is soft. It is to say Earth keeps enough things in working order all at once for life to continue. That is a quieter and more powerful idea. It means the livability of this planet is not a mood. It is a system. And once you start to see that, a new question begins to form. If habitability is really the result of many conditions working together, then which conditions matter most? And how did Earth settle into this careful range in the first place? Every day, Earth receives a quiet stream of energy from the sun. It arrives so steadily that most of us almost stop noticing it. Morning light spreads across walls. Warmth gathers on pavement. Shadows shorten and drift. Plants lift toward it. Oceans take it in. Clouds reflect part of it away. From a human point of view, sunlight can feel simple. It brightens the day, warms the skin, and marks the passing of time. But on a planetary scale, sunlight is much more than that. It is one of the main reasons Earth can support life at all. To understand why Earth feels so workable, it helps to begin with where Earth is. Earth orbits the Sun at a distance that allows the planet to receive enough energy for liquid water to exist across the surface, but not so much that the entire world is pushed into constant, unbearable heat. This region around a star is often called the habitable zone. That phrase can sound dramatic, but the idea is simple. It means a range of distances where temperatures may allow liquid water to remain stable, especially if a planet also has the right atmosphere and surface conditions. Earth sits within that range. This does not mean Earth is sitting in one perfect spot where nothing can ever go wrong. It means Earth is close enough to the Sun to receive useful warmth, while still far enough away to avoid the extreme conditions found on hotter worlds. In other words, Earth begins with a helpful starting position. That starting position matters because sunlight is the main outside source of energy, driving many of Earth's systems. It helps warm the land and oceans. It powers weather. It fuels photosynthesis in plants, algae, and other organisms that turn sunlight into stored chemical energy. It helps move water through the cycle of evaporation, clouds, and rain. Even the differences between climates across the planet begin partly with how sunlight reaches different regions. But sunlight alone is not the full answer. If Earth was simply a rock sitting at this distance from the Sun, with no atmosphere, no oceans, and no other balancing systems, the human experience of this planet would feel very different. Some places would become much hotter in sunlight and much colder in darkness. Surface conditions would swing more sharply. Water would not behave in the same way. So Earth's place in sunlight is best understood as the beginning of the story, not the whole story. Still, it is an important beginning. Imagine moving Earth much closer to the Sun. The planet would receive more incoming energy, Over time, that would place much greater stress on its systems. Now imagine moving it much farther away. The world would grow colder, and stable surface water would become harder to maintain. The point is not that Earth must be exactly where it is to survive, but that its general distance places it in a favorable range. It starts from a workable amount of sunlight. There is also another quiet advantage to Earth's orbit. It is fairly close to circular, which helps keep the yearly flow of solar energy more even than it would be in a very stretched orbit. Earth does move slightly closer to and farther from the Sun during the year, but this difference is small compared with the effect of Earth's tilt, which is what mainly drives the seasons. So while Earth's orbit is not perfectly round, it is regular enough to support a steady long-term pattern. That regularity matters. Life does well with patterns. Days repeat. Seasons return. Warmth changes, but not wildly from one year to the next. A planet does not have to be unchanging to be habitable. In fact, some variation can be helpful, but variation works best when it stays inside a range that living systems can adapt to. Earth's path around the Sun helps create that kind of repeated structure. From the ground, this may all feel very far away. Most people do not wake up thinking about orbital distance. They think about whether the morning feels cold, whether the room is bright, whether the season seems to be shifting. But those simple experiences are tied to something much larger. The calm arrival of daylight each day depends on Earth being a planet in motion, circling a star at a distance that allows warmth without constant ruin. That is part of what makes Earth feel so quietly fortunate. The Sun gives Earth the energy that life needs, but Earth receives it in a range that can be worked with. Not too little, not too much. Enough to begin building oceans, weather, ecosystems, and long repeating cycles. Enough to make a habitable world possible. And once that sunlight arrives, the next question is just as important. What does Earth do with all that energy after it gets here? Earth does not simply receive sunlight. It has to manage it. That may be one of the quietest reasons Earth stays livable. Every moment, energy is arriving from the Sun, spreading across clouds, oceans, forests, deserts, ice, and cities. If all of that energy stayed, Earth would keep warming. If too much of it escaped too easily, the planet would grow far colder. So habitability depends not just on getting sunlight, but on balancing what comes in with what goes back out. This is what scientists mean when they talk about Earth's energy balance. Some of the sunlight that reaches Earth is reflected back into space almost right away. Bright clouds do this. Ice and snow do it well too. Pale deserts reflect more than dark forests. The ocean reflects some light at certain angles, but it also absorbs a great deal. The land does the same. So from the start, the planet is sorting sunlight in different ways, depending on what kind of surface or sky it meets. Overall, not all incoming sunlight stays on Earth. A meaningful share is reflected away, and the rest is absorbed by the atmosphere, the land, and the oceans. Once that energy is absorbed, it does not disappear. It changes form. Sunlit ground grows warm. Water stores heat. Air moves. Ice melts. Winds begin. Clouds form. The surface of Earth then releases energy back upward, mainly as heat. So Earth is constantly doing two things at once. It is taking in energy from the sun, and it is sending energy back out into space. If those two flows stay close to balance over long periods, the planet remains within a workable range. If that balance changes too much, the whole climate system shifts with it. That is why this idea matters so much. The energy balance is not some distant technical detail. It sits underneath the daily experience of weather, seasons, and temperature. You can think of it like a long-running exchange. Day after day, Earth receives a deposit of sunlight. Day after day, it returns energy to space. The habitability of the planet depends on that exchange not drifting too far in either direction for too long. This balance is shaped by many parts of Earth at once. Clouds reflect sunlight, but they can also help trap heat below. Ice cools the planet by reflecting more sunlight, while darker surfaces like forests and oceans absorb more energy. Water stores heat slowly and releases it slowly. The atmosphere absorbs some energy directly and moves warmth from one place to another. Even the angle of sunlight matters, which is why the equator and the poles do not receive the same amount of energy. So the energy balance is not controlled by one switch. It is the result of many small processes acting together. That is part of what makes Earth feel so steady from a human point of view. Most people do not notice this exchange happening. We notice that a clear summer afternoon feels bright and warm. We notice that snow can feel dazzling under the sun. We notice that cloudy nights often feel different from clear ones. But underneath those everyday experiences is a much larger planetary pattern. Earth is always deciding, in a physical sense, how much energy to reflect, how much to absorb, where to store it, and how quickly to release it again. Even the beauty of the world is tied to this balance. The gleam of polar ice, the whiteness of clouds, the darkness of deep ocean water, the warmth of sunlit stone. All of these are part of the same energy story. A cloud is not only something soft and beautiful overhead, it is also part of how Earth manages incoming sunlight. Ice is not only something cold beneath your feet, it is also one of the planet's brighter surfaces, sending energy back into space. This helps explain why Earth does not feel like a world of constant extremes. It is not because sunlight is weak. It is because the planet has ways of handling that sunlight once it arrives. And that brings us a little deeper into the system. Because one of the most important tools Earth uses in this balance is the atmosphere, which does something remarkable. It allows sunlight in, but slows some of the heat trying to leave. One of the quietest reasons Earth stays livable is that the planet does not lose all of its warmth as soon as the sun goes down. If it did, Earth would feel like a far harsher place. Days might still bring light, but the warmth would vanish too easily. Nights would become far colder. Water would struggle to remain liquid across much of the surface. The familiar rhythm of warm afternoons and cool evenings would be replaced by much sharper swings. Life, at least as we know it, would be living on a much less forgiving world. This is where the natural greenhouse effect comes in. The name can sound complicated, but the basic idea is simple. Sunlight passes through the atmosphere and warms the land and oceans. The surface then releases some of that energy back upward as heat. Certain gases in the atmosphere slow part of that heat from escaping too quickly into space. They do not trap all of it. Earth still loses heat, but they help the planet hold onto enough warmth to stay within a livable range. That quiet slowing makes an enormous difference. Without Earth's natural greenhouse effect, the planet's average temperature would be far below what it is now. Instead of being a world where liquid water can exist across much of the surface, Earth would be much colder on average. The life people know, from forests and farms to rivers and coastlines, depends in part on this invisible warming effect overhead. So the greenhouse effect is not a mistake in nature. In its natural form, it is one of the reasons Earth works. The most important greenhouse gases include water vapor, carbon dioxide, and a few others present in smaller amounts. Even though some of these gases make up only a small part of the atmosphere, they still matter because they interact with heat in a way that most of the air does not. Nitrogen and oxygen make up most of the atmosphere, but greenhouse gases play a special role in slowing the escape of warmth. You can think of it as a kind of thermal blanket, though not a perfect one. A blanket does not create heat from nothing. It helps slow the loss of heat that is already there. Earth's atmosphere works in a similar way. It helps keep the surface from cooling too quickly, especially over long periods. This is one reason the planet feels stable enough for life to settle in. From a human point of view, the greenhouse effect hides inside ordinary experiences. It is there in the fact that the world does not become deeply frozen every night. It is there in the fact that lakes, rivers, and oceans can remain liquid. It is there in the slow release of warmth after sunset, when the ground and air cool gradually rather than all at once. The atmosphere is doing quiet work that most people never feel directly, even while they benefit from it every day. What makes this especially interesting is that the greenhouse effect is part of a balance, not just a source of warmth. Earth still has to release energy back into space. If no heat could escape, the planet would keep warming. If heat escaped too easily, the planet would become far colder. So the atmosphere helps by slowing some of that loss, not stopping it. That balance is what makes the system so effective. Enough sunlight gets in, enough heat gets out, but not all of it leaves at once. This is also why Earth feels different from a world with no meaningful atmosphere. A bare, rocky surface in space can heat up strongly in sunlight and cool down sharply in darkness. Earth is different because air, water, and greenhouse gases all help soften those extremes. The result is not a planet with no variation, but a planet where variation stays within a range life can work with. So when we talk about Earth being balanced, this is one of the clearest examples of what that means. The atmosphere is not only something above us, it is part of the reason the surface feels calm enough, warm enough, and steady enough for daily life to unfold. And yet the atmosphere does more than hold heat. It also works with clouds, which can both reflect sunlight away and help keep warmth below. A cloudy day often feels different from a clear one, even before rain begins. The light is softer. Shadows weaken. The sky feels lower, closer somehow, as if a layer has been drawn across the world. On some days, clouds make the afternoon feel cooler and quieter. On other nights, a blanket of cloud can make the darkness feel less sharp, less cold, as though some of the day's warmth has been left behind. These changes are gentle, but they reveal something important. the sky is not empty space above our heads. It is active, shifting, and responsive. And clouds are one of the clearest signs of that. Clouds help shape Earth's balance in two main ways. First, they can reflect sunlight back into space. This is why thick clouds often make a day feel dimmer and cooler than a clear one. When sunlight meets a bright cloud top, some of that incoming energy is sent away before it ever reaches the ground. In that sense, clouds can act a little like mirrors. They help reduce how much solar energy the surface absorbs. This is one reason cloudy summer days can feel so different from cloudless ones. Even if the sun is still above, less of its energy reaches the land directly. The world below remains lit, but the heating is softened. At the same time, clouds can also help hold heat below. After the ground warms during the day, it releases energy back upward as heat. On a clear night, more of that heat can escape into the open sky. But when clouds are present, they can absorb and re-emit some of that outgoing heat, slowing its loss. This is why cloudy nights can sometimes feel milder than clear ones. The clouds are not creating new warmth. They are helping some of the existing warmth linger longer. So clouds do something interesting. During the day, they may cool the surface by reflecting sunlight. At night, they may help keep the surface a little warmer by slowing how quickly heat escapes. In simple terms, they can act like mirrors and blankets, depending on the situation. That does not mean every cloud behaves the same way. Thin, high clouds and thick, low clouds can affect light and heat differently. Some clouds are bright and dense, reflecting a lot of sunlight. Others are wispy and let more light through. Some help cool more strongly during the day. Others matter more at night. But the larger point remains the same. Clouds are not passive decoration. They are part of how Earth manages energy from hour to hour and place to place. This makes them one of the most visible parts of the planet's balancing system. You can see them forming, moving, thickening, breaking apart, and changing shape. They drift over oceans, gather over mountains, stretch across plains, and rise with warm air from the land below. A cloud is not just a shape in the sky. It is a sign that air, water, sunlight, and temperature are interacting in real time. That is part of why clouds feel so alive. They respond to warmth rising from the surface. They respond to cooling air. They respond to wind, moisture, and the shape of the land. A still grey layer overhead, a line of towering summer clouds, a thin veil before sunset. Each one shows that the atmosphere is always in motion, always adjusting. From a human point of view, this can feel deeply familiar. People know what it is like to step outside and notice that a cloudy sky changes the whole mood of the day. The world may look softer. The temperature may feel gentler. Evening may come earlier. A cloudy night may seem quieter and less exposed than a clear one filled with sharp stars. These are ordinary experiences, but they are tied to a real physical process. The sky is constantly helping decide how much sunlight arrives below and how quickly warmth leaves again. So when we look up at clouds, we are not only seeing weather, we are seeing part of Earth's energy system in action. And even as clouds move across the sky, the ground beneath them is moving too. Because Earth does not only sit under sunlight and weather, it turns slowly through them, carrying every ocean, forest, city, and field from daylight into darkness and back again. One of the quietest rhythms on Earth is the steady turning of day into night. It happens so faithfully that most of us stop thinking about it very early in life. Morning arrives, light spreads, afternoon brightens and softens. Evening lowers itself over streets, fields, coastlines, and rooftops. Then darkness comes, and after enough time, light returns again. The pattern feels natural because it is so regular. But this daily rhythm exists because Earth is turning. Earth spins on its axis once about every 24 hours, more exactly about 23.9 hours. That turning is what makes the sun seem to rise in the east, cross the sky, and set in the west. In truth, it is not the sun circling Earth each day. It is Earth rotating, carrying each place gradually into sunlight and then back into darkness. This may sound simple, but it has enormous consequences for life. If Earth did not rotate, one side of the planet would face the sun for extremely long stretches, while the other side would remain in darkness for just as long. The sunlit side would grow much hotter. The dark side would grow far colder. Instead of the gentle daily exchange between warmth and cooling that we know, the planet would experience much harsher contrasts between light and dark regions. Rotation helps prevent that. By turning steadily, Earth spreads sunlight around. No place remains under the sun forever, and no place remains away from it forever either. Heating happens, but it is shared in time. Cooling happens too, but not without relief. Every place moves through a cycle. Light arrives, warmth builds, light fades, cooling follows, and then the pattern begins again. This daily movement helps keep Earth within a livable range. Of course, temperatures still vary from place to place. Deserts can grow hot. Polar nights can become bitterly cold. High mountains cool more than low valleys. But the turning of Earth stops the whole system from splitting too sharply into a permanent hot side and a permanent frozen side. Rotation gives the planet a kind of thermal rhythm. From a human point of view, that rhythm shapes almost everything. It shapes sleep and waking. It shapes work and rest. It shapes the opening of flowers, the movement of tides with the moon and coast, the songs of birds, the hunting times of animals, and the structure of human calendars and routines. Dawn and dusk are not small events. They are part of the larger breathing pattern of the planet. Even the feel of time is connected to this turning. A day is not only a unit on a clock. It is a physical event. It is the time it takes for one full rotation of Earth. Every sunrise is a reminder that the ground beneath us is moving, even when it feels perfectly still. Every sunset is a sign that we are being carried out of the light again. That may be one of the strangest quiet truths about ordinary life. We spend our days on a rotating world and barely notice. The speed of this turning is also more interesting than it first appears. At the equator, Earth's surface is moving fastest because it has the largest circle to travel in one rotation. Places farther north or south move in smaller circles, and so travel more slowly in that sense. Yet everywhere on Earth shares the same rotation period. The whole planet turns together, though each latitude traces its own path through space. This turning also helps drive other systems. As Earth rotates, sunlight does not heat all parts of the surface equally at the same time. That creates temperature differences, which help move air and influence winds. The same is true for land and water, which warm and cool at different rates. So rotation is not only giving us days and nights, it is also helping set the stage for weather and circulation. What makes all this feel so calm is the regularity of it. Earth does not jerk from daylight into darkness. It turns smoothly. Light spreads gradually. Shadows lengthen slowly. Evening does not arrive like a switch being flipped. It arrives because a turning planet is carrying your place on its surface, gently out of the sun's direct view. That is part of why day and night feel so natural. They are not interruptions in Earth's balance. They are one of its main patterns. And Earth does not only turn, it also leans. That lean changes how sunlight falls across the planet through the year, which is why the rhythm of day and night expands into something larger and slower, the familiar pattern of the seasons. One of the most comforting things about Earth is that change often arrives in patterns. The air cools, then warms again. Leaves appear, deepen, and fall. Days lengthen, then shorten. Sunlight shifts across windows, fields, and roads in ways that can be felt long before they are measured. For most people, the seasons are not only a fact of science. They are part of memory. They shape clothing, routines, holidays, crops, school years, migrations, and the quiet feeling that time is moving forward in a familiar way. This steady pattern exists because Earth is tilted. Earth's axis, the imaginary line it spins around, is tilted by about 23.4 degrees. That may sound like a small detail, but it changes how sunlight reaches different parts of the planet during the year. As Earth travels around the sun, the tilt causes each hemisphere to lean toward the sun for part of the year and away from it for another part. When a hemisphere leans toward the sun, it receives more direct sunlight and longer days. When it leans away, sunlight arrives at a lower angle and the days grow shorter. That is what creates the seasons. Many people first imagine that summer happens when Earth is closer to the sun, and winter happens when it is farther away. It sounds reasonable, but that is not the main cause. Earth's distance from the sun changes only a little through the year, and in fact, Earth is slightly closer to the sun during part of the northern hemisphere's winter. The seasons come mostly from the tilt, not from major changes in distance. This matters because it shows how Earth's balance is built through geometry as much as warmth. The angle of sunlight changes how concentrated it is when it reaches the surface. When sunlight arrives more directly, the same amount of solar energy is spread over a smaller area, so heating is stronger. When sunlight arrives at a lower angle, the same energy is spread across a wider area, and the heating is weaker. Lower angle light also passes through more atmosphere, which further softens its intensity. So the difference between summer and winter is not that the sun suddenly grows stronger or weaker. It is that the way its light reaches the ground changes. Day length matters too. When a hemisphere leans toward the sun, it not only gets more direct light, but also more hours of it. That gives the ground, water, and air more time to warm. When the same hemisphere leans away, daylight hours shorten, and the surface has less time to gather warmth. Over time, this creates the broad seasonal shifts people know so well. And yet, Earth seasons usually do not feel chaotic. They feel patterned. That is one of the most important things about them. The planet changes, but it changes in a way life can prepare for. Plants bud when light returns. Animals migrate, nest, or rest according to repeating signals. Human beings build calendars, harvests, clothing habits, and expectations around these cycles. Even the feeling of the year depends on this predictability. The first cool air of autumn, the slow return of spring light, the long evenings of summer, and the low, pale sun of winter all make sense because Earth's tilt creates a pattern that returns again and again. This is another example of Earth being active without being wild. The planet is not frozen in one state, and that is part of what makes it so rich. But its changes usually stay within a range that can be lived with. There are hot places and cold places, early springs and late winters, long summers and short ones depending on where you live. Even so, the larger structure remains. Earth leans, Earth orbits, and sunlight shifts in a repeated rhythm. From a human point of view, this may be one of the easiest parts of planetary science to feel directly. You do not have to understand angles or orbits to notice that winter light feels different from summer light. You do not need a diagram to feel the longer days arriving after a dark season. The science is large, but the experience is intimate. That may be why the seasons feel so calming to think about. They are proof that motion does not have to mean disorder. Earth is moving quickly through space, tilted as it goes, and yet that movement creates one of the gentlest forms of order people know. And even as sunlight changes through the year, Earth has another quiet stabilizer working beside it. The oceans remember heat more slowly than land does, which helps soften the sharpness of seasonal change and makes the planet feel steadier than sunlight alone would suggest. One of the quiet reasons Earth feels so steady is that water does not react to heat as quickly as land does. You can feel this on an ordinary warm day near the coast. The sand may grow hot under your feet, while the sea still feels cool. Later, after sunset, the sand begins to lose its warmth faster, while the water changes more slowly. That small experience points to something much larger. The oceans do not warm and cool as quickly as the land, and because of that, they help soften Earth's temperature extremes. This happens because water has a high specific heat. In simple terms, that means water can absorb a lot of heat before its temperature changes very much. Land responds faster. It heats quickly under strong sunlight and cools more quickly after the sun goes down. Water is slower in both directions. It takes longer to warm, and it takes longer to cool. That slowness matters more than it may seem. If Earth were made mostly of land, temperatures in many places would likely swing more sharply between day and night, and between one season and the next. But because so much of the planet is covered by water, and especially by deep oceans, a great deal of heat can be stored and released gradually. The oceans act like a slow memory of warmth. This is one reason coastal climates often feel gentler than inland ones. Places near large bodies of water usually experience less extreme temperature change than places far from them. In summer, the nearby ocean can help keep the air from heating as quickly as land farther inland. In winter, that same water can release stored heat more slowly, helping keep nearby temperatures from falling as sharply. The result is not a perfect sameness, but a softening. The presence of water helps smooth the edges. From a human point of view, this is deeply familiar, even if most people never name the reason. A coast often feels different from the interior. Sea air can feel cooler in daytime heat and milder when the land begins to chill. Islands, shorelines, and harbor cities often carry this slower rhythm with them. Water changes the feel of a place. The same is true across the seasons. Land responds quickly to changing sunlight. Water responds more slowly. That delay helps keep Earth from reacting too sharply to each shift in the sun's angle. When summer sunlight strengthens, the oceans do not instantly become hot. They absorb energy over time. When winter arrives, they do not immediately lose all that stored heat. They release it more slowly. In this way, water helps quiet the extremes that sunlight alone might create. This makes the oceans more than scenery. They are part of the planet's temperature system. And because the oceans are so large, this effect happens on a huge scale. Water covers most of Earth's surface. Day after day, season after season, it takes in sunlight, stores part of that energy, and gives some of it back later. It does not do this all at once. That is exactly why it matters. The steadiness comes from the delay. You might think of it as the difference between a thin metal tray and a thick stone floor left in the sun. One changes quickly, the other takes longer. Water is like the slower material in Earth's climate system. It does not hurry. That slow response also helps living things. Plants, animals, and human communities often do better in places where temperature change is less sudden. A world with gentler swings is easier to adapt to. It gives ecosystems more continuity. It gives weather patterns more structure. It helps turn constant solar energy into something the surface can live with. Even the feel of evening near water can reflect this process. The light fades, the ground cools, but the ocean, lake, or sea nearby is still holding part of the day inside it. That lingering warmth does not always make the air feel warm, but it changes how quickly the world loses heat. Water slows the exit. That may be one of the best ways to understand Earth's oceans in this section. They are not only places where life exists. They are giant keepers of thermal memory. They remember warmth longer than the land does. And yet the ocean does not only hold heat, it also moves it. Water is always shifting, sinking, rising, and flowing across the planet. So the warmth stored by the sea does not stay in one place forever. Earth has another quiet system built on top of this one, where currents carry heat from warmer regions toward cooler ones and help connect distant parts of the world into one larger pattern. The ocean does not keep its warmth in one place. That is one of the reasons it matters so much. If the sea only stored heat and never moved it, Earth would still be different from a land-only world, but not as balanced as it is now. What makes the oceans even more powerful is that they are always in motion. Warm water flows away from the tropics. Cooler water moves in other directions. Surface currents and deeper currents connect distant parts of the planet into one long, slow system. In this way, the ocean does not just remember heat, it redistributes it. This helps make Earth feel more even than sunlight alone would suggest. The equator receives more direct sunlight than the poles do. If energy simply stayed where it arrived, the hottest places would become even hotter, and the coldest places would remain even more isolated from warmth. But Earth has systems that move energy around. Winds do some of this in the atmosphere, and ocean currents do some of it through water. Together, they help reduce the contrast. Ocean currents are driven by several forces. Wind pushes surface water across great distances. Earth's rotation helps curve those movements into large circulating patterns. Differences in temperature and saltiness also matter because they affect density. Colder or saltier water is denser and tends to sink, while warmer or fresher water is lighter and tends to stay higher. This creates a slow vertical movement as well as horizontal flow. So the ocean is not only moving across the surface, it is also turning over in depth. Some currents are easy to notice on maps because they flow along coastlines or across ocean basins. Others move more quietly through the deep sea. Together, they form a connected circulation system that carries heat, oxygen, nutrients, and dissolved gases around the planet. One well-known example is the Atlantic overturning circulation. In simple terms, warm surface water moves northward through the Atlantic. As it loses heat to the air and becomes denser, some of it sinks and begins a slower return flow at depth. This is only one part of a much larger global system, but it helps show the basic idea. Ocean water can carry warmth into cooler regions, then change and continue moving in another form. That matters for climate. Places touched by warm currents can feel milder than other places at the same latitude. Coasts influenced by cooler currents may feel different in the opposite direction. The sea helps shape not only the weather over water, but also the character of air that moves onto land. That is why the ocean is never truly separate from life on shore. A shoreline climate is partly a conversation between land, water, and moving air. From a human point of view, this can be hard to see all at once because the system is so large. Most people do not stand at the coast and think about heat being carried across an ocean basin. They just notice that one place feels milder than another, or that the sea seems to temper the air. But beneath those experiences is a vast movement of water, quietly shifting energy from one part of the world to another. It also helps to remember that the ocean moves slowly compared with weather. A storm can change in hours. A wind can shift in a day. Ocean currents can take far longer, and that slowness is part of their power. They are not quick adjustments. They are long-running transfers. They take the heat stored in water and spread its influence over time and distance. The sea also connects surface life to deeper layers of the world. As water moves, it helps mix gases and supports the exchange of oxygen and carbon dioxide. It helps bring nutrients upward in some places and carry materials away in others. So currents are not just temperature pathways. They are part of Earth's larger life support system. That is what makes the oceans feel less like separate bodies of water and more like one connected engine. The Atlantic, Pacific, Indian, Southern, and Arctic oceans may have different names, but the water itself belongs to one planetary system. It moves through basins around continents, across the equator, and into the deep. It links warm places to cool ones, surface motion to deep silence, and local coastlines to distant regions far beyond sight. This gives Earth a kind of hidden unity. Warmth gathered under tropical sunlight does not always remain there. Some of it begins a journey. It travels in water, is shared with air, and changes climates far away. The sea becomes a carrier, not just a container. And this moving water does not remain only in the ocean. Again and again, it rises into the air as vapor, gathers into cloud, falls as rain, and returns through rivers, soil, and groundwater. The water of Earth is always on the move, which means the next part of the story is not about the sea alone, but about the whole cycle linking sky, land, and ocean together. On Earth, water is never truly still for long. It may rest for a while in an ocean, a lake, a cloud, a patch of snow, a river bend, or deep underground. It may sit quietly on a leaf after rain, or gather in a glass beside a bed. But over time, water keeps moving. It rises, drifts, falls, seeps, flows, freezes, melts, and returns again. This constant motion is called the water cycle, and it is one of the main reasons Earth feels alive, connected, and workable. The water cycle begins, in a simple sense, with sunlight. When sunlight warms oceans, lakes, rivers, and damp soil, some water gains enough energy to rise into the air as vapor. This process is called evaporation. Plants also release water vapor through their leaves, which adds more moisture to the atmosphere. Together, these processes move water upward from the surface into the air, even when the change is invisible. That invisibility is part of what makes the cycle so easy to overlook. A puddle shrinks, wet ground dries, laundry left outside becomes lighter and less damp. These can feel like ordinary events, but they are all part of water leaving the surface and entering the air. Slowly and quietly, the atmosphere fills with moisture. As this moist air rises or cools, the water vapor can begin to gather into tiny droplets or ice crystals. This is called condensation. When enough of these tiny droplets gather together, clouds form. So a cloud is not just a shape floating overhead. It is a sign that water has traveled upward, changed form, and become visible again. From there, the cycle continues. When droplets in clouds grow large enough, they fall back to Earth as precipitation. That can mean rain, snow, sleet, or hail, depending on temperature and conditions in the air. Some of this water falls directly into oceans. Some lands on forests, fields, rooftops, roads, and mountains. Some soaks into the soil. Some runs across the surface into streams and rivers. Some becomes groundwater, moving slowly beneath our feet through cracks and spaces in rock and soil. This is what gives the cycle its feeling of connection. Rain falling on a hillside may travel into a stream, then into a river, then into the sea. Water that sinks into the ground may move very slowly and later emerge in a spring. Snow resting on a mountain may melt months later and feed the same river system. Mist may rise from the ocean, become cloud, cross land, and fall as rain far inland. Water is always changing form and location, but it remains part of one linked planetary loop. That loop touches daily life constantly. Every sip of water has a history. The water in a cup may once have been in a lake, a cloud, a glacier, a river, or the open sea. The rain on a window, the fog over a field, the dew on grass, the stream under a bridge, and the steam rising from a shower all belong to the same larger system. Earth's water is not scattered into separate stories. It is one story moving through many forms. The cycle also helps keep Earth balanced. As water evaporates, it carries heat away from the surface. As it condenses in the atmosphere, that heat is released again. Clouds form, rain falls, rivers flow, and moisture shifts from one place to another. So the water cycle is not only moving water, it is also helping move energy. It links the warmth of sunlight to the motion of air, the growth of plants, the filling of rivers, and the shape of weather. This is one reason Earth feels so responsive. A warm day can help build clouds. Cooling air can bring mist. A storm can refill dry ground. A mountain can lift moist air and help turn it into rain or snow. The planet is not only covered in water, it is constantly circulating it. There is also something calming about how familiar this cycle feels. People have always watched rain gather, rivers move, frost melt, and clouds drift. Long before anyone had a scientific name for evaporation or groundwater, the cycle was already present in daily life. It could be heard in roof rain, seen in morning dew, and felt in the coolness after a storm. The science is large, but the experience is close. And yet, for all this motion, the water cycle depends on something invisible that makes surface water possible in the first place. For rain to fall as liquid, for rivers to run openly, and for oceans to spread across the surface instead of behaving in a very different way, Earth needs more than water alone. It also needs air, and especially the pressure of that air surrounding the planet at just the right strength for liquid water to remain stable here at the surface. Air can feel so ordinary that it almost disappears from thought. We breathe it without planning to. We walk through it without seeing it. We notice it mostly when it moves, when wind brushes the skin, when a storm passes through, or when cold air greets the face at a doorway. But Earth's atmosphere is much more than something living things happen to breathe. It is one of the main reasons this planet feels steady, protected, and alive. The atmosphere is the layer of gases surrounding Earth. In simple terms, it is made mostly of nitrogen, then oxygen, with much smaller amounts of other gases such as argon, carbon dioxide, and water vapor. Those smaller ingredients may seem unimportant because there is less of them, but they matter a great deal. Water vapor helps shape weather and clouds. Carbon dioxide helps the planet hold on to some warmth. Together, all these gases form a blanket around Earth. Not a solid one, but a shifting, responsive layer that changes how the planet works. Without this layer, Earth would feel far harsher. The atmosphere helps soften temperature swings between day and night. It helps move heat from one region to another through winds and weather. It carries moisture, builds clouds, and helps turn sunlight, warmth, and water into the changing patterns people experience as climate and daily weather. In that sense, the air is not only surrounding the world, it is helping organize it. That is one reason the atmosphere feels so alive. It is always moving. Warm air rises. Cooler air sinks. Moisture gathers, drifts, and falls. Winds cross oceans and plains. Storms build, shift, and fade. Even on a calm day, the atmosphere is still at work above us, layering, circulating, and responding to changes in heat and moisture. The sky may look empty, but it is never inactive. From a human point of view, this can be easy to forget, because we live inside it all the time. Fish might not pause often to think about water, In a similar way, people do not often stop to think about air as a system. Yet the atmosphere shapes nearly every outdoor experience. The feel of morning coolness, the gathering of clouds before rain, the softness of fog, the dryness of desert air, the heaviness before a storm. All of these come from the character of the atmosphere in motion. It also protects the planet in quieter ways. The atmosphere helps hold in enough warmth for Earth to remain livable. It helps spread energy around rather than letting each place respond alone to sunlight and darkness. It supports the water cycle by carrying vapor upward and helping return it as rain or snow. It also forms the medium through which sound travels, which means even the ordinary act of hearing birds, rain, wind, or distant voices depends on the presence of air. That can make the atmosphere feel less like empty space and more like a living envelope around the planet. It surrounds Earth from surface to sky, growing thinner with height, yet still remaining part of the same connected system. Mountains rise into it, clouds float within it, birds travel through it, sunlight passes through it and changes because of it. Heat moves through it. Water cycles through it. Life depends on it constantly. And the atmosphere does all this while remaining mostly invisible. That invisibility may be part of why it feels so easy to overlook. We can see clouds, but not the air holding them. We can see leaves bend, but not the wind itself. We can see waves, dust, and smoke being moved, but not the transparent layer making motion possible. The atmosphere often reveals itself only through what it touches. Still, its effects are everywhere. A world without an atmosphere would not feel like a gentler version of Earth. It would be a different kind of place entirely, with sharper temperature swings, no familiar weather, no open breathing, and no easy movement of water through cloud and rain. Much of what makes Earth feel calm and workable depends on this invisible layer surrounding it from all sides. And one of the quietest things this air provides is something most people never feel directly at all. It provides pressure, pressing gently on the world at every moment, helping liquid water remain stable at the surface and making ordinary life possible in ways that are easy to miss. One of the strangest facts about ordinary life on Earth is that liquid water depends on something we cannot see. Most people think of water staying liquid as normal. A glass on a table, rain falling from clouds, a lake holding still in the morning light, a river moving around stones. All of it feels natural. But water does not stay liquid everywhere, and it does not do so automatically. Part of what allows it to remain stable on Earth's surface is the pressure of the atmosphere pressing down from above. Air may seem light, but it has weight. All the air above you is being pulled by gravity toward Earth, and that creates pressure at the surface. We do not usually feel that pressure in a dramatic way, because our bodies are used to it. We live inside it all the time. But it is there, quietly surrounding us, pressing on oceans, lakes, puddles, soil, plants, buildings, and skin. This pressure matters because it changes how water behaves. At Earth's surface, the atmosphere is thick enough and the pressure strong enough for liquid water to remain stable across a wide range of ordinary conditions. That is why rain can fall as liquid, why rivers can run openly, and why oceans can spread across the surface instead of vanishing into vapor or behaving in a far less familiar way. In a sense, the atmosphere helps hold open the middle state of water, Without enough pressure, water does not remain liquid so easily. Under very low pressure, it can shift more quickly between ice and vapor, with the liquid state becoming much harder to maintain. That may sound surprising, because most people think temperature alone decides whether water freezes, melts, or boils. Temperature matters greatly, of course, but pressure matters too. This is easier to understand if you think about boiling. Water does not always boil at exactly the same temperature in every situation. At higher elevations, where air pressure is lower, water boils at a lower temperature than it does at sea level. That is one simple everyday sign that pressure affects water's behavior. The lower the pressure, the easier it is for liquid water to escape into vapor. Now imagine this effect taken much farther. On a world with very little atmospheric pressure, stable liquid water at the surface becomes difficult. Water may freeze when it is cold and turn into vapor when conditions shift. But the middle state people know so well becomes much less reliable. Earth is different because the atmosphere does not only provide gases and weather, it also creates the pressure needed for liquid water to remain part of daily planetary life. This means one of the most familiar features of Earth depends on something almost invisible. Rain falling from a cloud is not only about moisture and gravity, it is also about a planet with enough atmosphere to support liquid water on the way down and after it lands. A pond does not only depend on a hollow in the ground and a source of water. It depends on air pressing down around it. A wave breaking on a shore is not only a matter of wind and water. It is happening in a world where the surface pressure allows that water to remain liquid in the first place. That makes air pressure feel less like a technical detail and more like a hidden requirement of ordinary life. People rarely walk outside and think, the pressure around me is helping rivers stay rivers. Yet it is. The same is true for lakes, rainfall, wet soil, morning dew, and the water inside every living cell. So much of what feels normal depends on a condition most people never directly notice. There is something calming about that thought. Earth's habitability is not built only from dramatic things like sunlight, oceans, or magnetic fields. It is also built from gentle constants, quiet conditions, background facts that hold steady enough for life to go on without interruption. Surface pressure is one of those facts. It does not ask for attention, but it changes almost everything. It also reminds us that Earth's atmosphere is doing more than sitting above the ground. It is actively shaping what the surface can be. The world feels familiar partly because water can remain open and flowing. Streams can move downhill. Rain can collect in puddles. Wet leaves can glisten after a storm. Lakes can reflect morning light without becoming something far stranger. These are peaceful sights, but they depend on a very specific planetary condition. And the atmosphere protects in another way too. It does not only help water remain liquid. Higher up, it also filters part of the sun's more harmful ultraviolet light before that light reaches the ground, helping make sunlight safer for life at the surface. High above the weather, most people know, the atmosphere is still doing quiet work. Far above the clouds that bring rain, above the winds that move across forests and oceans, and above the air that people breathe each day, there is a region of the atmosphere where one small ingredient matters a great deal. This is the ozone layer, part of the upper atmosphere that helps filter sunlight before it reaches the ground. Ozone is a form of oxygen, but instead of 2 oxygen atoms joined together, it has 3. That small difference changes how it behaves. In the upper atmosphere, ozone is especially good at absorbing much of the sun's ultraviolet radiation, often called UV light. This kind of light has more energy than the visible light people can see, and too much of it can damage living tissue. So the ozone layer acts like a filter. It does not block all sunlight. If it did, Earth would feel like a much darker world. Instead, it helps remove much of the more harmful ultraviolet light, while still allowing visible sunlight to pass through. The result is a planet that remains bright and warm, but where the surface is far safer for life than it would be without that filtering. This is one of the most interesting things about Earth's atmosphere. It does not simply let sunlight in or keep it out. It shapes the kind of light that reaches the ground. Most people never see the ozone layer directly. It does not appear in the sky as a visible band. It does not move like clouds or arrive like weather. Yet it is there, quietly changing the sunlight that touches oceans, forests, fields, cities, skin, leaves, and water. It is one of those planetary systems that stays almost completely in the background, while helping make ordinary life possible. From a human point of view, this can be easy to overlook because sunlight feels so natural. Morning light through a window, brightness on pavement, the warm gold of afternoon, the glow on the surface of water. These feel like direct gifts from the sun. And in a broad sense they are. But the light reaching Earth's surface has already passed through layers of air. It has already been filtered, scattered, and shaped by the atmosphere on the way down. The ozone layer is part of that shaping. It sits mainly in a region of the atmosphere called the stratosphere, well above the lower air where most weather happens. There, ozone forms and breaks apart in a repeating process driven by sunlight itself. So even this shield is not completely still. It is maintained through ongoing chemical change, quietly renewing itself high above the ground. That makes the ozone layer feel less like a fixed wall and more like a living filter. Its importance becomes clearer when imagined in reverse. Without this protective layer, much more harmful ultraviolet light would reach Earth's surface. Life in open sunlight would face a harsher environment. The land and sea would still receive light, but not in the same gentle form. Earth would remain bright, but less safe. That is why this part of the atmosphere fits so well into the larger story of balance. Again and again, Earth does not survive by blocking everything or by allowing everything through. It works through moderation. Some heat is held, but not all. Some sunlight is reflected, but not all. Some radiation is filtered, but visible light still arrives. The planet remains livable, not because every outside force is stopped, but because many of them are softened, sorted, and shaped into a workable range. The ozone layer is one of the clearest examples of that. It lets the surface stay open to daylight, while reducing one of the risks carried inside sunlight itself. The world remains bright enough for photosynthesis, vision, warmth, and daily life, yet protected enough that light does not arrive in its full harshness. There is something calming in that idea. Even the sunlight touching the ground has already been gently adjusted before it reaches us. So when people stand in daylight, they are not only standing under the sun, they are standing under a filtered sun, one that has passed through a protective envelope of air and reached the surface in a form more suitable for life. And the same air that filters light also protects Earth in another way. It does not only change what arrives from the sun, it also helps defend the surface from many small objects coming in from space, turning the night sky itself into part of the planet's shield. The night sky can feel peaceful because it seems so open. Stars shine through it. The moon crosses it. Meteors sometimes flash for a moment and disappear. Most of the time, the darkness above looks like empty space, stretching quietly over the world. But Earth's sky is not only a window upward, it is also part of the planet's defense. Every day, small pieces of space material enter Earth's atmosphere. Some are tiny grains, smaller than sand. Others are larger bits of rock or metal drifting through space. If Earth had no atmosphere, many more of these objects would strike the surface directly. But because the planet is wrapped in air, many of them never make it that far. As these small objects race into the atmosphere, they meet air at very high speed. That sudden contact creates intense heating. The object compresses the air in front of it, and both the air and the object grow extremely hot. Many small pieces burn up or break apart before they can reach the ground. From below, this often appears as a meteor, a brief streak of light moving across the sky. What looks beautiful and delicate to a person watching from the ground is often the visible sign of the atmosphere doing protective work. That is what makes this so easy to miss. A shooting star does not usually feel like a shield in action. It feels like a quiet moment, something lucky or beautiful. But in many cases, that line of light marks the destruction of a small object that would otherwise have continued downward. The atmosphere is not only something that carries weather and softens temperature, it also takes the first contact with much of what falls toward Earth from space. This gives the sky a different kind of meaning. It is not just empty room above the planet. It is a working boundary. It slows, heats, and often destroys small incoming debris before that debris can become a problem at the surface. In that sense, the atmosphere acts as a shield made of air. Of course, not every object burns up completely. Larger pieces can sometimes survive the passage and reach the ground as meteorites, but many smaller ones never do. Earth is constantly moving through space, and space is not perfectly clean. Dust, fragments, and rocky bits cross the planet's path all the time. The reason people are not constantly struck by this material is partly because the atmosphere stands in between. From a human point of view, this is one of the most surprising parts of Earth's balance. Air feels soft. It bends grass, carries birds, and cools skin. It hardly seems like something that could stop falling rock from space. Yet speed changes everything. At the enormous speeds involved, even thin upper air becomes a barrier. The object meets resistance, heats rapidly, and often loses itself in the process. So the gentleness of air at human scale hides a kind of strength at planetary scale. That contrast is part of what makes Earth so interesting. Again and again, familiar things turn out to be doing more than they seem. Clouds are not only scenery. Oceans are not only water. And the atmosphere is not only something living things breathe. It is also a protective envelope that faces the outside world first. This protection has likely shaped human feeling for a very long time, even before people understood the science behind it. A meteor crossing the night sky can stir wonder because it feels like a message from beyond the ordinary world. But the deeper truth is that the atmosphere is turning that distant object into light before it can become something more dangerous. Beauty and protection are meeting in the same event. That fits perfectly with the larger pattern of Earth's habitability. The planet often remains safe not through dramatic walls or sharp borders, but through quiet processes that keep harmful things from reaching the surface in full force. Heat is softened. Radiation is filtered. Small impacts are burned away. Earth stays livable, partly because outside forces are shaped into gentler forms before they arrive where life is. And the atmosphere changes not only survival, but also appearance. The same air that can turn falling debris into brief streaks of light also changes the look of the world every day. It helps make the sky blue, softens daylight, and turns sunrise and sunset into glowing color. In other words, the atmosphere does not only protect Earth, it also helps create the beauty people associate with being here. Some of Earth's protection can be seen, even if most people do not think of it that way. The daytime sky looks blue. Sunsets glow with orange, red, and gold. The world softens under evening light, and morning often begins with a pale wash of color spreading through the air. These are among the most familiar sights on Earth. They can feel so ordinary that they are easy to take for granted. But they happen because sunlight is moving through the atmosphere, and the atmosphere is changing that light on its way to us. Sunlight may look white at first glance, but it is really made of many colors mixed together. Each color travels as a different wavelength of light. Some have shorter wavelengths, like blue and violet. Others have longer wavelengths, like red and orange. As sunlight enters Earth's atmosphere, it runs into tiny particles and gas molecules in the air. These tiny parts of the atmosphere scatter shorter wavelengths more easily than longer ones. That is the basic reason the sky looks blue. Blue light gets scattered in many directions as sunlight passes through the air, and that scattered blue light reaches our eyes from all across the sky. So when you look upward on a clear day, you are not really seeing the emptiness of space. You are seeing sunlight being spread through the atmosphere. In a way, the blue sky is a visible sign that Earth has air. Without an atmosphere, the sky would not look like this. It would be dark even during the day, more like the sky seen from the moon. The familiar blue above us depends on sunlight meeting air and being redirected. That means one of the most ordinary sights on Earth is also one of the clearest signs that this planet is wrapped in a protective layer. Sunsets and sunrises work through the same process, but the path of light changes. When the sun is high in the sky, its light passes through less atmosphere before reaching you. But when the sun is low near the horizon, the light has to travel through much more air. Along that longer path, more of the shorter blue wavelengths are scattered away before the light reaches your eyes directly. What remains is richer in longer wavelengths, which is why the sun and the sky around it can glow with warmer colors like orange, red, and gold. So a sunset is not only a beautiful ending to the day, it is also a lesson in how air shapes light. The atmosphere is filtering, scattering, and sorting sunlight as it passes through. The glowing horizon is a reminder that the air above us is active even when it feels still. It is not simply there to be breathed. It is constantly changing how the world looks. From a human point of view, this is one of the gentlest examples of Earth's balance. The same atmosphere that holds warmth, carries weather, and burns up many small meteoroids also creates blue afternoons and glowing evenings. Protection and beauty are happening through the same layer of air. That may be one reason the sky feels so calming to look at. Its colors are not random. They come from a real physical process, one that connects the sun, the atmosphere, and human sight. Blue midday skies, pale winter light, deep orange sunsets, and soft pink dawn clouds all belong to the same story. Light enters, air changes it. The world looks the way it does because Earth is surrounded by a transparent but active envelope. Even haze, mist, and dust can add to this effect. When more particles are present in the air, the color and softness of light can change again. Sunrises may seem more muted, or sunsets more intense. Daylight can feel sharp and clear, or soft and silver. The atmosphere is always shaping what reaches the eye. This makes the sky feel less like empty space and more like part of Earth's surface experience. A person standing outside is never only under the sun. They are under sunlight that has already passed through miles of air. That air has already scattered some colors, softened some brightness, and changed the appearance of the world before the light ever reaches the ground. So the beauty of the sky is not separate from Earth's life-supporting systems. It is one of the most visible expressions of them. And yet many of Earth's protections cannot be seen so easily at all. Some stay almost fully invisible, stretched far above the atmosphere itself, quietly shielding the planet from streams of charged particles flowing outward from the sun. Earth has a protective shield that most people never feel directly. It does not look like clouds. It does not move like weather. It does not glow across the whole sky each night. And yet it surrounds the planet all the same, extending far out into space as an invisible field of protection. This is the magnetosphere, Earth's magnetic shield, and it helps guard the planet from charged particles flowing outward from the sun. The sun is not only a source of light and warmth, it also sends out a steady stream of fast-moving charged particles called the solar wind. These particles spread outward through space in all directions. If a planet has little or no magnetic protection, that flow can interact much more directly with its atmosphere and surface. Over very long spans of time, this can help wear away the outer layers of a planet's air. It can also expose the planet more fully to energetic particles that would otherwise be deflected or redirected. Earth is different because it has a strong global magnetic field. That field reaches outward and forms a protective region around the planet. When the solar wind arrives, the magnetosphere helps push much of it around Earth, instead of letting it strike the atmosphere head-on everywhere. In that sense, the magnetosphere acts a little like an umbrella, not blocking every drop completely, but changing the path of what comes toward the planet and reducing its direct force. This is one of the quietest forms of protection Earth has. Most people never wake up thinking about magnetic shielding. You cannot hear it. You cannot watch it drift by like a cloud. You cannot feel it on your skin the way you feel wind or sunlight. Yet it is there all the time, shaping Earth's relationship with space. It helps preserve the atmosphere, and in doing so, it helps protect many of the other systems life depends on. That is part of what makes the magnetosphere so interesting. It protects something that then protects us. The atmosphere holds warmth, carries weather, filters light, and helps water remain liquid. The magnetosphere, in turn, helps defend that atmosphere from the constant flow of solar particles. So even though the magnetic shield sits farther out, high beyond the air most people know, it is still tied closely to life at the surface. A gentle comparison with Mars helps make this easier to picture. Mars once had conditions that may have allowed rivers and lakes long ago, but today it has a much thinner atmosphere than Earth. Mars does not have the same kind of strong global magnetic shield Earth has now. Over immense spans of time, the interaction between the solar wind and the Martian atmosphere likely played a part in stripping away some of that air. Mars still holds great scientific interest, but it also offers a quiet contrast. It shows how different a planet can become when some of the systems that help maintain habitability weaken or disappear. Earth, by contrast, still holds onto a thick enough atmosphere to support surface pressure, weather, and liquid water. The magnetosphere is not the only reason for that, but it is one important part of the larger balance. This makes the magnetic field feel less like an abstract feature and more like part of Earth's life support system. From a human point of view, it is easy to forget that Earth is not only a place of oceans, forests, and skies. It is also a world sitting in space, exposed to radiation, solar activity, and particle flow from its star. The magnetosphere is part of what lets Earth remain a surface world instead of feeling fully exposed to that outer environment. There is also something calming in the fact that such an invisible system can matter so much. Earth often stays livable, not because all danger is removed, but because many risks are softened before they reach the ground. Heat is moderated. Ultraviolet light is filtered. Small meteoroids burn up, and charged particles are deflected high above the atmosphere. Again and again, the planet remains workable because outside forces are being shaped into gentler forms. The magnetosphere fits beautifully into that pattern. It reminds us that some of Earth's most important protections are not the ones we can easily see. They are the ones quietly holding their place in the background, making ordinary life possible without ever asking for attention. And this invisible shield is not coming from nowhere. It exists because Earth is active deep inside, far below the oceans, mountains, and continents, where moving material in the outer core helps generate the magnetic field that reaches all the way into space. Beneath the ground we walk on, Earth is not still. The surface can make a planet feel solid and settled and hold firm. Mountains seem permanent. Fields, forests, and coastlines appear to rest on something quiet and dependable. But below that thin outer layer, Earth is built in levels, and the deeper you go, the stranger and more active it becomes. To understand where Earth's magnetic shield comes from, we have to move downward, far below weather, oceans, and stone, into the layered interior of the planet. The outermost layer is the crust. This is the thin shell of rock that forms the continents and the floors of the oceans. Compared with the size of Earth as a whole, the crust is very thin. Below it lies the mantle, a much thicker layer of hot rock. The mantle is solid in one sense, but over long periods it can slowly flow. Beneath the mantle lies the core, which is divided into two parts: a liquid outer core and a solid inner core. That liquid outer core is where this part of the story becomes especially important. It is made mostly of iron and nickel, heated to enormous temperatures. Even though it is extremely hot, the pressure conditions and composition there allow the outer core to remain liquid. And because that liquid metal can move, it does not sit quietly in place. It swirls, shifts, and circulates deep inside the planet. Those motions matter because the material in the outer core can conduct electricity. When electrically conducting liquid moves inside a rotating planet, it can help generate a magnetic field. This process is called the geodynamo. The word may sound technical, but the basic idea is simple enough. Deep inside Earth, moving liquid metal acts like part of a giant natural generator, helping create the magnetic field that extends far into space around the planet. So the invisible shield above us begins with motion far below us. That is one of the most remarkable parts of Earth's balance. The magnetic field is not an added feature sitting outside the planet by itself. It is connected to the deep interior. The same Earth that grows forests, holds oceans, and carries clouds is also turning and circulating molten metal in its core. And that hidden motion helps create protection far beyond the atmosphere. This makes the deep Earth feel less like a dead center and more like a living engine. From the surface, it is easy to imagine the ground beneath us becoming quieter and quieter with depth, as if the planet was simply a stack of heavier and heavier material. But Earth's interior is dynamic. Heat left from the planet's formation, along with heat released by radioactive decay inside Earth, helps keep the interior active. That heat drives motion in the mantle and helps maintain the conditions that keep the outer core in movement as well. The inner core is different. It is mostly solid, even though it is hotter than the outer core. That may seem strange at first, but pressure increases greatly toward Earth's center, and that pressure helps keep the inner core solid despite the heat. So deep inside Earth, there is a solid center surrounded by a vast layer of moving liquid metal. Together, these layers help make Earth the kind of planet it is. A smaller world cools faster. A world with a less active interior may lose some of the deep motion that supports long-term planetary change. Earth, by contrast, has remained geologically alive for immense spans of time. Its interior still matters. Its deep heat still matters. Its moving core still matters. From a human point of view, this is almost impossible to feel directly. A person standing in a quiet field does not sense the outer core turning below. A city street gives no sign that thousands of kilometers down, liquid iron is in motion. Yet the effects reach all the way back to the surface. The magnetic field that helps shield Earth from solar particles depends on this hidden activity. The planet's protection begins in darkness, pressure, and heat. There is something calming in that thought too. Earth is not protected by a fragile surface trick. It is protected in part by something rooted deeply in the planet's own structure. The shield above is connected to the life within the planet itself. And sometimes this hidden shield reveals itself in light. Near the poles, charged particles guided by Earth's magnetic field can meet gases high in the atmosphere and make them glow. turning an invisible planetary defense into one of the most beautiful sights in the sky. The northern and southern lights can feel like one of Earth's quietest miracles. They drift across the dark in soft curtains, pale arcs, and shifting waves of color. Sometimes they glow faintly, almost like a mist of light. Other times they ripple and brighten, moving slowly across the sky as if the darkness itself has begun to breathe. To anyone watching from the ground, an aurora can feel dreamlike, but it is also something else. It is one of the few times Earth's invisible shield becomes visible. The story begins far above the weather, where Earth's magnetic field reaches out into space. The sun sends out a steady flow of charged particles called the solar wind. Most of the time, Earth's magnetic field helps redirect much of that flow around the planet. But near the poles, the shape of the magnetic field allows some of these charged particles to be guided downward along magnetic lines into the upper atmosphere. There, they meet gases high above the surface. When these charged particles collide with atoms and molecules in the atmosphere, they transfer energy to them. Those gases then release that energy as light. This is what creates the aurora. In simple terms, the sky glows because particles from space are being guided by Earth's magnetic field into the atmosphere, where their energy is turned into color. That means an aurora is not only something beautiful to look at, it is also evidence that Earth's protective system is active. The magnetic field is doing what it does, shaping the path of charged particles and preventing them from spreading more directly across the planet. The atmosphere is also doing its part, absorbing that energy high above the ground. The result is a display of light, but beneath the beauty is a process of protection. This is what makes auroras such a perfect part of Earth's story. They are gentle to watch, yet they come from powerful forces. The solar wind begins at the sun. Earth's magnetic field reaches far into space. The atmosphere receives the guided particles high near the poles. And from the ground, all of this can appear as a soft green or red glow, moving silently across the night. The colors themselves depend on which gases are being affected and how high in the atmosphere the collisions happen. Oxygen often produces green light, which is one of the most common aurora colors people notice. Under some conditions, oxygen can also produce red. Nitrogen can add purples, blues, or pink tones. The exact mix depends on altitude, energy, and the kinds of collisions taking place. So even the beauty of the aurora is tied closely to the chemistry of Earth's upper air. From a human point of view, this can feel especially moving because auroras seem both distant and personal. At the same time, they are happening far above the surface, in a region most people will never touch. And yet, they unfold in the same sky people have always looked up at. A child watching from snow, a traveler standing near a dark shore, someone looking out from a quiet town in the north. All of them are seeing the same larger truth. Earth is not only a world under the sky, it is a world protected within space. There is also something calming in the way auroras reveal a system rather than an accident. The lights are not random decorations. They are not separate from Earth's balance. They happen because the planet has a magnetic field, an atmosphere, and a place in a flowing stream of solar particles. The aurora is what it looks like when several of Earth's protective systems meet in one visible event. That turns beauty into understanding. The glowing sky becomes more than a spectacle. It becomes a sign that the invisible machine is running. The shield above is not just imagined. It is present, active, and sometimes bright enough to be seen. Of course, protection above is only part of Earth's balance. The sky filters light, burns up many small objects, and helps deflect charged particles. But habitability is not maintained from above alone. The ground beneath us is active too. Mountains rise, ocean floors spread, continents drift. New rock forms while older rock is drawn back down into the planet. Earth stays livable not only because it is shielded from space, but because its surface itself keeps changing over immense spans of time. Protection above is only part of Earth's balance. The ground beneath us is moving too. The ground beneath us can feel like the most stable part of Earth. Roads stay where they are. Hills seem settled. Coastlines look fixed on a human timescale. Mountains appear ancient and unmoving. It is easy to think of stone as the quiet opposite of clouds, wind, and water. But Earth's surface is not one unbroken shell sitting forever in place. It is broken into large moving pieces, and over immense spans of time, those pieces drift, collide, pull apart, and sink back down. This is plate tectonics. Earth's outer shell is made of the crust and the uppermost part of the mantle together. This outer layer is broken into plates, like enormous slabs fitted side by side across the planet's surface. These plates move very slowly, usually only a few centimeters each year. That is about as fast as fingernails grow. On a human timescale, it feels like almost nothing. On a planetary timescale, it changes the face of the world. The motion comes from heat deep inside Earth. That inner heat helps drive slow movement in the mantle below the plates. The mantle is solid rock, but over very long periods it can flow slowly. As heat moves upward from deeper inside the planet, it helps set material in motion. The plates above are carried, pulled, and pushed by this larger system. So the continents are not fixed islands of stone. They are passengers on a slowly shifting outer shell. Where plates meet, Earth becomes especially active. Some plates move apart. When this happens, molten material can rise from below and form new crust. This is happening along long ridges on the ocean floor, where the seafloor slowly spreads outward. Other plates move toward one another. One may slide beneath another and sink back into the mantle, a process called subduction. In other places, plates grind sideways past each other, storing and releasing energy as earthquakes. These interactions shape the planet. Mountains can rise where plates collide. Volcanoes can form where one plate sinks beneath another, or where deep heat finds a path upward. Ocean basins can widen where plates pull apart. Earthquakes remind us that even rock can store motion for a long time and then release it suddenly. The surface may look still, but it is part of a larger system that never fully stops. This means Earth's surface is not only changing, it is being renewed. New crust forms in some places. Older crust is recycled in others. Continents drift and rearrange over immense spans of time. Seas open and close. Mountain ranges rise, wear down, and rise elsewhere. The world people know today is only one moment in a much longer story of moving stone. That motion helps make Earth livable over deep time. A planet with a completely frozen surface and no large-scale recycling would be a different kind of world. Earth's activity helps move heat from the interior outward. It helps shape landforms, build mountains, and refresh parts of the crust. Just as importantly, plate tectonics links the surface to the deeper planet. It allows materials from the surface to be drawn downward and allows materials from below to return upward again. Earth is not sealed shut. It exchanges matter between surface and interior. From a human point of view, this is hard to feel because the motion is usually so slow. A person standing in a valley cannot sense a continent drifting. A coastline does not seem to move as you watch it. Yet over millions of years, these motions are enough to rearrange oceans and continents. The world map itself is temporary. There is something calming in that too. Earth stays balanced not by becoming rigid and unchanging, but by remaining active in a slow and patient way. The same planet that turns through day and night, moves water through clouds and rivers, and carries light through air also reshapes its own surface from below. Change is built into the system. And one of the deepest things tectonics helps regulate is not stone alone, but the air itself. As rocks rise, break down, sink, melt, and return through volcanism, they become part of a much longer cycle that helps move carbon between the land, the oceans, the atmosphere, and the deep earth. In that way, plate tectonics does more than build mountains and ocean floors. Over immense spans of time, it helps Earth manage its climate too. One of the slowest systems keeping Earth livable is also one of the most important. It does not move like wind. It does not shine like sunlight or flow like a river. It works so gradually that no human being could watch a full cycle unfold from beginning to end. And yet, over immense spans of time, it helps keep Earth's climate from drifting too far in one direction. This is the carbon cycle, and in its deepest form, it acts a little like a slow planetary thermostat. Carbon moves through many parts of Earth at once. It can be found in the atmosphere as carbon dioxide. It can be dissolved in ocean water. It can be stored in living things, in soil, in shells, in limestone, and in other kinds of rock. It can also be carried deep into Earth and later returned through volcanic activity. So carbon is not fixed in one place. It is always moving, though some parts of the journey are much faster than others. Some parts of the carbon cycle happen quickly. Plants take in carbon dioxide from the air during photosynthesis. Animals eat plants, breathe, and return some carbon to the atmosphere. Leaves fall, wood decays, and soils exchange carbon with the air and water around them. Oceans also absorb carbon dioxide from the atmosphere and release some back again. These shorter movements are important, but there is another part of the cycle that matters especially for Earth's long-term balance. That deeper part involves rock, rain, and time. When carbon dioxide is in the atmosphere, some of it mixes with rainwater. This makes the water slightly acidic, though usually very weakly so. Over long periods, that rainwater helps weather certain rocks at Earth's surface. In simple terms, the rock slowly breaks down through chemical reactions, and carbon becomes part of the materials carried away by rivers toward the ocean. Eventually, some of that carbon can become locked into sediments and rock. It may settle into the seafloor, become part of shells or limestone, or be buried over very long stretches of time. In this way, carbon that was once in the air can end up stored in the solid earth. But the story does not end there. Because Earth is geologically active, some of that buried carbon can later be drawn downward by plate tectonics, heated, and eventually return through volcanism. So carbon is cycling between air, water, life, rock, and the deep planet. This is what makes the system feel like a thermostat. Over immense spans of time, when Earth grows warmer, weathering can increase in some ways, helping remove more carbon dioxide from the atmosphere and store it in rock. When Earth is colder, some of these processes may slow, allowing volcanic return and other sources to play a larger role over time. The response is not quick. It does not correct the climate from one season to the next. But over millions of years, it helps pull Earth back from the extremes. That slowness is part of its strength. A thermostat in a house works quickly enough for daily comfort. Earth's carbon thermostat works on a planetary timescale. It is not there to make every year the same. It is there to help keep the long-term climate within a range where oceans, weather, and life can continue. From a human point of view, this system is almost impossible to see directly. No one watches a mountain weather into climate balance in an afternoon. No one sees carbon enter limestone and then return through volcanism across millions of years. But the quiet truth remains. The air above us is connected to rain, rock, rivers, oceans, seafloors, plate tectonics, and deep Earth heat in one enormous cycle. That means Earth's climate is not held in place by the atmosphere alone. The land helps regulate it. The oceans help regulate it. Life helps shape it. And the planet's own geology helps move carbon between reservoirs in ways that matter profoundly over deep time. Earth stays balanced not because one system does everything, but because many systems overlap and support one another. There is something deeply calming in that idea. The stability of this planet is not fragile in the sense of depending on one single condition. It is layered. The atmosphere holds warmth. Water stores and moves heat. Plate tectonics keeps the surface and deep Earth connected. And the carbon cycle slowly links air, sea, rock, and fire into one long balancing process. This is one of the clearest signs that Earth is not only alive at the surface. It is maintained through connections stretching from the sky to the sea floor and down into the planet itself. And now, with sunlight, air, water, stone, and deep planetary motion all in view, we can begin to bring the whole picture together. Because Earth feels ordinary only when all of these systems are quietly working at once. And so, as this quiet journey comes to a close, we return to the simple feeling of being here. A planet can seem ordinary when you have lived on it your whole life. The air feels normal, water feels normal, morning light feels normal. The turning of day into night, the passing of seasons, the softness of clouds, the steady pull of gravity, the glow of the sky, all of it can slip so easily into the background. But now, perhaps, Earth feels a little different. Not less familiar, just more deeply understood. Because beneath that feeling of normal life, so much is quietly happening. Sunlight is arriving and being balanced. The atmosphere is holding warmth, carrying weather, filtering light, and softening the sharpness of space. Water is rising, falling, flowing, and storing heat with patient care. Oceans are moving warmth around the planet. The magnetic field is stretching outward, helping shield the world from the solar wind. Deep below the surface, Earth's interior is still active, still shaping the planet from within. And over immense spans of time, stone, air, water, and life have kept working together to help this world remain livable. Earth feels ordinary only because so much is quietly going right. That may be one of the most calming ideas in science. The world does not rest on one single lucky condition. It rests on many systems, layered together, helping one another, adjusting, moving, and holding this planet within a range where rivers can flow, forests can grow, clouds can gather, and living things can wake beneath the morning sky. It is easy to think of habitability as something dramatic, something rare and distant and almost impossible to picture. But tonight, it may feel closer than that. It may feel like air in the lungs, water in a glass, cool evening light, the sound of rain, the warmth left in stone after sunset, the familiar comfort of standing on solid ground without having to wonder whether it will hold. That is the quiet gift of Earth. Not perfection, not stillness, not a world without change, but a world where change often stays within a range that life can live with. A world active enough to keep itself going, and gentle enough, much of the time, to let life rest upon it. So wherever you are tonight, perhaps in a dark room, beneath a window, beneath a roof, beneath clouds, or stars, or city light, you are resting on a planet that has been quietly maintaining these conditions all along. And in that way, Earth is not only a place we live on, it is a place that, in countless visible and invisible ways, has been making life possible every moment we have been here. Thank you for spending this time with me. If you enjoyed this quiet journey through the science of Earth, please subscribe. And if you'd like, leave a comment sharing where you're listening from tonight. For now, let the planet keep turning. Let the air stay soft around you. Let the ground remain steady beneath you. And let the ordinary feeling of being here grow just a little more wondrous as you rest. Sleep well, friend.